Okay, good morning to everybody. Today we'll learn actually what is the line integral and the application of line integrals in a complex plane. That means, first of all, what is complex line integral? Complex line integral. Complex line integral. Let the complex function f of z f of z is the complex function of complex variable be continuous at all points of a rectifiable curve of a rectifiable curve rectifiable curve C whose starting and ending points are A and B. Starting points A and B respectively. Okay, respectively. Let us divide the whole rectified curve C into an equal parts at Z1, Z2, up to what? How many parts will be Zn? So let total sum of the whole length of the rectified curve C, Sn can be denoted by Z1 minus Z0 into f of del 1 plus Z2 minus Z1 into f of del 2 plus plus Zn minus Zn minus 1 f of del n. Okay, so for a representation of a curve, we can draw this curve like this. Suppose the curve starting from here and going up and then in this way. Okay, so this is the whole curve C and starting point at from this. That means from Z equals to what? Z0. Okay, starting from point A, Z0. Okay, this Z0 equals to what? A. And we can suppose there are another point Z1 and this is the whole curve C, rectifying curve C. And suppose there are Zk minus 1. And this is also Zk. Suppose this is Zk. So suppose this point is the Zn minus 1 and this point Zn which is equals to B. That means we are dividing the whole curve C into different parts. One is del 1, this part is del 1. Okay, and this part is del 2. Okay, del 2, and this part will be what? Del k. Okay, and this part will be del n, difference. So this is the along x-axis, this is the along x-axis, and this is the along y-axis. So if we go from, this is the x-axis length, this is the z naught. Suppose this is the length and this is length. This difference what? Z1 minus Z naught. So Z1 minus Z naught is the length on along what? X-axis. So this is the length, and we get corresponding value of del f of del 1. That means along y-axis. This is the f of del. Okay. For every values of Z1, Z2, we get f of del. So f of del 1 will be the corresponding value of y. So the area bounded by this region, we get this area. Along x-axis, this length, and this is the along y-axis breadth. So this whole area can be found by this. For the first 2 points only, Z0 and Z1. Similarly, for the second length what will be? Z2 minus Z1, because we have denoted Z1, Z2, Z dot, Zn. First of all, we can take Z0 here, starting from Z0. So another second length will be what? Z2 minus Z1, and corresponding length along y-axis what will be? F of del 2. So this whole area, second part and third part, in the dot dot, in the last nth part will be what? Zn minus Zn minus 1. That means this whole area will be given by this part. So Zn minus Zn minus 1, this is the length along x-axis, and we get corresponding value of along y-axis f of del n. So for this part, Zn minus 1 to Zn, we get this area. So total area denoted by this Sn. Understand, everybody? So this whole area bounded by the whole curve C can be represented by like this: summation k equals to 1 to n zk minus zk minus 1. This is the actually length along what? X-axis. So corresponding to length along y-axis will be this. Okay, f of del, and this will be del k, because we are summing with a summation. Okay, so this del k will be the length along what? Y-axis. So length multiply breadth will be area. For k equals to 1, we get first area. For k equals to 2, we get second area. For k equals to k, we get last area. So this is the whole area bounded by the whole rectifying curve C. Remember it. So where we can where z k minus 1 less equals to del k, let zk. Remember this del k must be lies between zk minus 1 and zk. That means zk minus 1 zk, every del k means what? Depending on k 1 to up to n. So this del k will lies between these two. Sorry, this will be zk lies between zk and zk minus 1. And this is the actually equation number 1 we can denote. If the division n increases in such a way that the chord length del k tends to 0, that means if del 1 is the a little bit difference. Okay, if del 1 is very negligible, then if del k tends to 0, decreasing, okay, along the y-axis length decreasing, so n increases in such a way that the chord, the del k absolute value, of course this will be positive, and this del k tends to 0, then this sum Sn, what will be? Tends to tends to a limit. Tends to a limit. That means depending on del k tends to 0, we get a limit of a sum. Okay. So which does not depend on, which does not depend on path. And in which path? It is not, does not depend if del k tends to 0. So the length of f of z, so hence the length f of z, is the main complex function. So this f of z over whole rectifying curve C, this whole curve C from A to B, from A to B can be denoted by this integration A to B f of z dz, or we can write rectifying curve C f of z dz. We can denote by a definite integral, and we can denote also, this is the C, whole curve C, integrand over the curve C f of z dz. We can denote that by this, and this can be denoted by this whole sum. Okay, k equals to 1 to infinite, because del k tends to 0, then k tends to what? Infinity. Remember it. Zk minus 1, this one, del k. Okay, f of del k, and this is equation number 2. So after integrating this whole curve C, we get this limit of sum, and this is called which is called the complex line integral. Complex line integral. That means this is the whole definition, complex line integral. That means we can, this total sum we can represent as a integration. Okay, and as a definite integral from A to B. Okay, the whole curve C. So this is the line integral. This is the whole line. C may be curve, but this is the whole line. So, and it is, and this integration sum of total area of this curve can be denoted by this integral, and this integral is called actually complex line integral. Okay, now first example of line integral, find the value of the integral, this integration of the rectifying curve C x plus y dx plus x square y dy. So there are two parts. First part, along y equals to x square curve having 0, 0 and 3, 9 and points, and along y equals to thrice x between the same points. Okay, do the values depends on path? So we are solving now actually using the line integral. First of all, the given line integral is what? This is the given line integral dx plus x square y dy. You must know this is a differential equation. You must know this. This is a differential equation. And for the first part, A, suppose P dx Q dy, suppose here P equals to what? X plus y. And Q equals to what will be? X square y. So del P del y, what will be? Del P del y, 1. And del Q del x, what will be? twice xy. So del p del y does not equals to what? Del p del x. Since this is not exact differential equation. So the integrals does not depend on path. It's not independent. That means depend on path. The integrals depend on path because this is not equal. This is why. So for the first part, we can draw the curve here like this. Y equals to x square. We can draw like this curve. This is the y equal to x square curve, and starting point what? 0 0 origin, and this is the x-axis and this is the y-axis. End points what will be? End points, suppose this is a point A and it is 3 9. Okay, along x-axis 3 and y along y-axis 9 ordinate. So for the first part, A given y equals to what? X square. So we can find dy equals to what will be? Twice x dx. Twice x dx. And this is equation number 1. Suppose this is equation number 1. So from equation 1, we can find the integral limit will be what? Integral limit 0 to what? X limit 0 to 3. Okay, x limit what? 0 to 3. So x plus y equals to what? X square dx, and x square y equals to what? X square dy equal to what? Twice x dx. Understand everybody? Just putting the value of y equals to x square here and dy equals to what? Twice x dx. So we get this one. This is the plus sign. We get easily integration. Integration what will be? This equals to 0 to 3 x plus x square plus x to the power 5 2x to the power 5 dx. Okay, so this can be written as integration what will be? X to the power n formula plus x cube by 3 plus 2x to the power 6 by 6, then limit 0 to what? 3 x limits, because this integration transformed to only dx with respect to x. So just putting 3 square by 2, 3 cube by 3, 2 into 3 to the power 6 by 6 minus all whole will be 0. So only this values. This values what? 9 by 2 plus 339 plus this will be what? 243. So this result will give the value of first part 256 and half. So this is the result for the first part. Understand everybody? Okay, now the second part will be B part, along what? Y equals to thrice x. Given y equals to what will be? Thrice x. So dy equals to what will be 3 into dx. Okay, then from equation 1 same, just putting, then from equation 1 just putting y equal to thrice x in the given equation 1. So x plus integration limit will be what, 0 to what, 3, x plus thrice x dx plus x square, y equals to what, y equals to what, thrice x, and dy equals to what, 3 dx. Okay, so from this line we can write xx what 0 to 3, xx what 4x plus, and this will be 339 9x cube dx. Simple integration, definite integral. So this can be written as 4 into x formula what, x square by 2 plus 9 into x to the power 4 by 4, and the limit 0 to 3, and this value what, actually just putting x equals to 3 we get the required result. Required result what will be 3 square 9, 9 4 by 2 will be only 2, 9 into 2 what, 18, 18 plus 3 to the power 4 means what, 81, 81 into 9 by 4, what will be 7 to 9 by 4, 7 to 9 by 4, that means 201 by 4. This is the required result. Is it visible for you? Hello, is it visible?
Yes, sir. This is visible.
Okay, thank you. Okay, now example 2, another one, evaluate the complex integration line integral 1 minus I2 2 plus I. The function is twice x plus iy plus 1 dz along the two paths. Two paths means their first path is x equals to t plus 1 and y equals to 2t square minus 1. And another one, the straight line joining these two points, complex points. This is the 1 minus I and this is the 2 plus I. 1 minus I means what? In Cartesian form, 1 minus 1 point. That means 2 1 points. Remember it. So in the solution, we can write for the first path only. Actually, for the first one, we can write, we are given what, x equals to what, t plus 1. So dx what will be, dt. Okay, dx what will be, dt, and y equals to what, 2t square plus, sorry, minus 1. So in that case, dy what will be 4t dt. Okay, so dz equals to what will be, you must know dz means what, dx plus I dy. Do you know? Just putting these values from here, we can write what, dx equals to what, dt, from here dt plus I dy equals to what, 4t dt. That means dt will be common. Dt will be common. That means 1 plus 4 I t dt. Okay. So dz equals to, we got 1 plus 4 I t dt. And the limits of the integrals are, the limit. So the limits of the integral what? 1 minus I and 2 plus I. Okay. 1 minus I means what? 1 minus 1 point in Cartesian form. And 2 plus I means what? 2 comma 1 in Cartesian form. So the corresponding these points, the corresponding these points, the limits of t are 0 and 1. How we get 0 and 1? Suppose if t equals to 0, if t equals to 0, then x equals to what? X equals to what? 1. Okay. And y equals to what? If t equals to 0, then we get y equals to what? Minus 1. So 1 minus 1. First point we got. Okay. First point we got. If t equals to 1, then x equals to what? X equals to 2. And y equals to what will be? 1. Y equals to what will be? Only 1. So this is why we are taking, because the whole parameter transforming to dz, remember it, dt, transforming to dt. So we are taking only values of various values of t. So the given equation, the given complex line integral can be written as what? 1 minus I to what? 2 plus I. So twice x plus iy, twice x plus iy plus 1 dz. This can be written as, we are transforming to parameter t. T values varies to 0 to 1 for these 2 points. Okay, we found. So twice x value what? T plus 1. Remember it. So 2t plus 1 plus I. Y value what? 2t square minus 1. 2t square minus 1 plus 1. And dt, dz value what? 1 plus 4it dt. Very easy. So first of all, multiplying one, this whole with 1, we can write 0 to 1, 2t plus 1 I 2t square minus 1 plus 1. Just multiplying this whole into 1 plus 4it into what? This whole. 2 into t plus 1 I into 2t square minus 1 plus 1 dt. Understand everybody? So 0 to 1, this will be what? Twice t plus 2 plus I into I can be common 2t square minus 1 4t. Okay, plus second there will be 2t plus 1, 2t plus 2 plus 1 plus I 2t square minus 1 dt. So we can separate into real and imaginary part. 2t plus 2 plus 2t plus 2 plus 1 plus I into what will be twice t square minus 1 4t plus 2t square minus 1. Just separating real and imaginary part, we get this one. And this is this integral 0 to 1. So after this line, we can write 2t what? 4t plus 2 to 5. I into, and this will be 2t 4t square plus 4t minus 2 dt. So simple integration with respect to t. Actually, this is the 4it. 4it. OST 4t into actually there is a mistake. 4it multiply this whole. Okay. So twice t plus 2 plus I into twice t square minus 1 plus 1. So 4it multiply this. What will be 8it I t t plus 1. Then I what will be I square means minus 1. So 4t 2t square minus 1 plus 4it, and this will be the actual multiplication dt. So after this line, we can write here 0 to 1, 0 to 1, just summing this one, we get uh, real part and imaginary part twice t plus 2 plus 1 minus 8t cube, just multiplying, we get 8t cube minus 8t cube plus 4t. This is the real part, and imaginary part will be like this: 2t square minus 1 plus 8t square plus 8t plus 4t dt. Just separating real and imaginary part, we get this one: 0 to 1 minus 8t cube plus 6t plus 3. Okay, plus I into what will be 2t square 8t square, what will be 10t square plus 12t. 8 and 4 what? 12t minus 1. with respect to t. So now just integrating, we get what will be minus 8. This will be t4 by 4 plus 6 into t square by 2 plus 3 thrice t, 0 to 1 plus I 10 into t cube by 3 plus 12 into t square by 2 minus only t, and putting the limit within third brackets 0 to 1. So we get, just putting t equals to 1 here, we only minus 2 plus 3 plus 3 plus I into, just putting, and this will be 10 by 3, 10 by 3, 6 minus 1. So the final integration of the first part will be this final result. Final result what? We get 4 plus 25 by 3 into I. This is the value of the line integral, complex line integral of first part. Now the second part, second part will be the equations of the straight line joining these 2 points. The equation of line joining 2 points. 2 points, what will be? 1 minus 1 and another one what? 2, 1. So you know the formula y minus y1, y minus y1 divided by y1 minus y2 equals to what? X minus x1 divided by x1 minus x2. This was the formula. So just putting x1, y1 and x2, y2. So we get y minus y1 what will be? Plus 1. And y1 minus y2 what? 1 equals to x minus x1 what? 1 and x1 minus x2 what? 2. So we get the line what? Actually y plus 1 equals to y plus 1 equals to minus this minus 2 and minus 1. So minus minus cancel. So twice x minus 2. So y equals to what? Y equals to twice x minus 3. And this is the line. So dy what will be from this line? Twice x dx. Okay. Twice x dx. So now the rectifying integrals, given integral, complex line integral twice x plus iy plus 1, and this is the dz. So this equals to, can be written as what? Integral limits will be what? 1 1 minus 1, another is 2 1. Okay. So 2 twice x plus I, y equals to what? This is given equation number 2. This is given twice x minus 3 plus 1. And dz equals to what? Dx plus I dy. You must know. So this can be written as this whole line just multiplying dx plus dy. But dy equals to, so integral limit will be what? 1 to 2. 1 to 2, x limit 1 to 2, twice x plus I, twice x minus 3 plus 1, dx plus dy equals to what? Twice x dx. Twice x dx. So this means 1 to 2, twice x plus I, we can 1 plus twice x dx. So 1 into this means what? I twice x minus 3 plus 1 plus twice x into 1 to 2. So from this line we can write actually limit 1 to 2, integral limit 1 to 2, twice x I, twice x minus 3 plus 1 plus 4 x square plus I, what will be 4x 6x, 4x square minus 6x plus twice x. Just separating real and imaginary part from this line integral of complex function, we get what? This one. Just separating real and imaginary one. 1 to 2, we get minus twice x, 6ix minus I plus 7. This one, dx. Now integrating minus 2 into x square by 2 plus 6I x square by 2 minus I into x plus 7x, and limit will be what? 1 to 2. So putting 2 square by 2 plus 6I 2 square by 2 minus I into 2 plus 7 into 2. Then putting minus 2 1 square by 2, 6I into 1 square by 2 minus I into 1 plus 7 into 1. Okay. So from this one, we get 4 plus 8I is the value of the integral, the equation of line joining two points. This one, this is the second part. This is the result of second part. Understand everybody? Now another example, evaluate the complex line integral 0 to 1 minus I x square minus iy dz along the path y equals to x and along the path y equals to x square curve. You must know we can draw these two curve like this. The curve will be what? We have drawn this one in earlier example. Okay. So y equals to x line will be like this. Okay. So and y equals to x square line will be like this. Okay. This is y equals to x square curve, and this is y equals to x curve. Okay. And starting point is 0 0, and their meeting point at what? Meeting point at 1 comma 1. Just solving, we get 1 and 1. So for the first part, a along y equals to x, dy what will be? Only dx. So dz what will be? Dx plus I dy, and dx dy means what? Also dx. So 1 plus I into what? Dx. Just putting dy equals to dx. So we get dz equals to what? Dz equals to 1 plus I dx. Then the given complex line integral 0 to 1 minus I x square minus I y dz can be transformed to just changing the variable y equals to x and dz equals to 1 plus I dx. We get what? 0 to 0 to what? 1, because the x variable changed to 0 to 1 from the figure. X square I y equals to what? Only x, and dz what will be? 1 plus I dx. Variable change, and x variable changed to 0 to 1 because real part of upper limit what? 1. Remember it. This is why 0 to 1. So here 1 plus I is the constant. So there no need to take integration of that. So x square integration what will be? X square integration x cube by 3 minus I x integration what will be? X square by 2 and 0 to 1. So from this line integral, we get 1 plus I, and just putting we x equals to 1, we get I by 2. This one. And this is the result. Just after multiplying, we get 1 into 1 by 3 minus I by 2